Welcome to the seventh video of object-oriented programming and second video of the basic of classes. In this video, we are going to see three different concepts connected to OOP, one by one: static members, then calling methods, and the classes, inner classes and method classes. Okay, static members. Let's start with the first concept. The methods and variables defined inside the class are called instance method and the instance variables. Why they are called as instance method? Because a separate copy of these variables and separate copy of the methods are created for the respective objects. That's why they are called as they are called instance variable and methods. That is, okay, separate copy of them is created upon the creation of each object. But in some cases, it is necessary to define a member that is common to all the objects and accessed without using a particular object. Okay, so is it possible that all the object will carry same method, same variable common? Okay, that is what member belongs to the class as a whole rather than object created from the class. Such members can be created by preceding them with a keyword static. So static keyword is used to create a variable or methods which can be common to all the objects of the class. So if you are knowing C static is a method by which you declare a variable locally, but its application, its initialization is done only once. Just carrying forward this particular concept in C++ and Java also, static is connected to object-oriented programming. Statics are used to declare the variable or the methods which are common to all the object of the class. The same copy is maintained throughout all the object of this class with the help of the keyword static. Okay, so see how static are declared. Static int cal, you can check it out. So cal is a static variable declared here. Static float min equal to 1. Okay, so that's what floating point min I given, and this is how methods are declared. Static void display, it contains one parameter. Okay, so static variables, actually one more application of static lies, but I'll show that when we see the concept of packages. I'll show the application of the static that time again. Now first let's continue with the first application of the static members here. So I'll go for the static members. Okay, let's see. A small simple program I've created here with to demonstrate the use of static keyword. See, one class I have declared here, class my work, and inside it a static variable x is equal to 10 is created. Okay, then one non-static variable which is we call as instance variable is equal to 1, and one method called as static void display, which is a static method created. Okay, it's only one copy is maintained through all the object of the class. That's why it is static. So I'll just revise the concept here. Main method is also static. It means that single copy of the main method is used for all the object of this class. That's why it is written as static. Okay, and this is instance method, which is a non-static method. Getting this? So non-static methods are increment and display is the static method. Okay, and now see how it is executed. So first of all, I just want to make sure that when static methods are declared, their objects are not expected to call them. See how this one, my work, directly the class name dot the method name I'm using here. With the help of this particular concept, I'm directly calling the static method here without creating the object, because if the method is common, then why to create the objects? Directly by using the class name also we can access it. If it's similar to C++ also, but in C++ there is a operator called as scope resolution operator is used to call the functions from the classes. But here we have the dot method, class name dot method name. I can access the static method by this particular mechanism. And if you want to access the variables, see this static int x equal to 10. So I'm accessing this by this method, by system.out.print my work dot x, directly class name dot variable name mechanism I'm using to access the static variables from the class. Okay, so this way we can access it, and this is how. Okay, so one more method I'm using here. I'm just printing this variable. This is a specially I mentioned there. See, by default the Java contains a class math in one of the package called java.lang. I'll explain that later words. And there's a variable called as pi. Value of pi is maintained inside the class math. Okay, and we are printing this value on pi. So it means that this variable which is declared inside the default class of Java math, which is default, I'm not done any operations there, I'm directly calling it everywhere it's possible. math is a class name, inside that pi is a static variable, and I am printing it directly on the screen by this mechanism. Now what about the non-static, that what instance variable and methods we can have? So to call them we need to create the objects. That's why I am creating object here, my work m. So m dot increment I can use, m dot increment 3 number of times I am calling, and then I am checking the output here on the screen. So we know that increment, m dot increment count will be incremented by 1, that is we are having 1 printed here, and then it is calling incrementing the values on the screen. If I run this particular code, check the output. Okay, see this one, that it gets initialized, value of x is 10, pi is equal to 3.14 something, then function call 1, function call 2, function call 3. Okay, so in this way these operations are executed here. But what's special in this? See, static method can call only static members, okay, not non-static members. It means that static has initialized, it's printed here, and I want to print the value of x after that. Okay, can I check it? It's printed, fine, because x is a static variable, it is accessed here. But can I access count? Check it. See, the error is printed, shown over here. Non-static variable count cannot be referenced from a static context. So static method can't access the non-static variable, means instance variables can't be called by this particular mechanism, because separate copy of count is maintained but separate copy of display is not maintained. So this is confusing over there, that's why it is not possible, it will show the error. Now here count is called because increment is general method, count is also general. What if I want to print, okay, here I will print the value of x, yes, accessing, fine. So non-static methods can access the static variables directly, but not vice versa, because static is common to all the objects, that's why anyone can call it, that's why it is separate copy is not maintained, obviously that's the reason why anyone can call it. Okay, so this is possible again in increment, just can check it out. Okay, but not vice versa is possible there. And if I make this particular method is static, see the error, now count I can't access because count is not static variable, that's the reason why it's showing the error over here. Okay, this is what the static concept means. Single copy is maintained throughout the all objects of the class, whether it is variable or a method. The concept is common. So when in Java's internal class hierarchy also, internal libraries also, this static concept is very regularly used. So when I want a particular object to be initiated without creating a separate copy of the method or variable, I'll be making them as the static. And how to use it? So this is how I can use the static variables and methods, and this is how I can use the instance variables and methods. In many classes we are having these static concepts created common. You just can see this one also, system.out.print. See, system is the class name. Why class name is used along with the object name? Okay, why? Because out is the static object, and to call the static object and its method I am using the class name here. See, this is very interesting concept that Java is internally using there, the concept of static for variable calls and for the method calls also. Okay, so remember this static, how do I make use of it, and most effectively we can apply in the programming also. Okay, so second topic, argument passing methods, argument passing to the methods. So when I call a function or a method, I can call it by two ways. Which are the two ways? Either we can call it by value or call by the reference. See, if you are knowing C++, you might be knowing the concept of call by reference. Call by value is common, almost all the methods or functions are called by values. But what about the references? C++ contains the pointer concept, but Java is not having the pointer concept. Then how it is possible to call a method by pointer or by reference? Yes, reference is different here. Reference means the object which is not allocated with the memory. That's what we call as reference, and it will have the similar impact in the output also when you call it by reference. So let's see how exactly the call by value and call by reference are differentiated. So we'll go for the call by value first. When I declare a method, and how can I make it call by value, that we'll see first. Call by value means simple value, whatever the methods that we have seen till, all different methods and their parameters, This is what we call as the call by value. By passing the parameters, by passing the constants, by passing the variables, we can call these directly here. That's what we call as call by value. So simple example I will show, because this example I am extending to the next concept of call by reference. That's why I'll be using this example here. Let's see how to do. I'm creating a class test. Math is the method I've declared, I and j. I'm incrementing I plus plus j plus plus. That's it. Simple operation I'm doing by using this method. And here test object is created, where I'm keeping variable a equal to 15, b is equal to 20. Okay, so before the calling a and b, I'm passing this parameter, printing it here. And now a here I passed, b here I passed, and after that, so when they are passed, this a will go here in I plus plus, then b will go in j plus plus. Okay, it means that this value of I and j are incremented by 1. Now what do you think, what will be the value of a and b after the call? Okay, what can be the value present over there? Now let's predict the output. Now see, a's value is passed into I and b's value is passed into j, means value of a and b are kept as it is, I and j are replaced. Only values we are passed, we haven't passed anything others. It means that if you are changing I and j, a and b will not be affected. So before the call and after the call, the output will be same. See, getting this? This is how simple is that. I'm passing this, I'm incrementing, I and j are local here and a and b are local here. That's why they are not having any direct relationship over there. I'm passing the values, and they are not changing the actual parameter and formal parameter also. They are not having, only replacing the values but nothing else. Now let's talk about the second concept of call by reference. So same program I just modified different way, and here I'll be passing the references now. What do you mean by reference? Reference means the variable of type class but not initialized with the memories. It's not an object. Okay, so how to do? So what I've done here, now a and b I have declared here, a and b or x and y, whatever. I just don't worry about that. Okay, and here to method I'm passing the reference variable. This is what we call a reference variable, test o. Okay, so test o is object of type test, and that o dot a plus plus I am doing, and o dot b plus plus I am doing. Just means when objects are passed, its internal variables values I am incrementing by 1. Okay, so let's call them. So here I am using a object test, and ob dot ob is the object, local object here, ob dot a 22, ob dot b 93. So this is how we have declared two variables here. Okay, so before calling ob dot a and ob dot b, I am printing here before call, and after that I am calling. So this object ob, which contains a and b, I am passing here, local object. This local object I am passing in o. So the ob is different here. Here I am having o. So o dot a plus plus 23 will become 22, b will become 23 here, and ob b plus plus, so it contains 93 here. It get incremented by 1, so 94. And here I am printing ob dot a and ob dot b. So what do you think? Will it change the content? Obviously it will change. What? See, when I am passing object as a parameter, then it is passed as a reference. It means that now when I pass ob to o, they will have the same memory, will have the common memory, because here o is reference variable. It's not an object, it's a reference variable. It is initialized when I pass this object to this reference variable, so they will access the same memory, that is the common memory there. It means that when you change the value of a and b by o, will affect the ob also. Okay, so they are now sharing common memory. So if they are sharing common memory, it means that o will affect ob and ob will affect o. This is what we call as call by reference. Check the output now. So before the call we are having 22 and 93, and after the call I am having 23 and 94. They are incremented by 1, means they are affected. Though ob is a local object here and o is a local object here, when you pass by this method, then their references will be same, and that references are affecting our output. Okay, that's what we have seen, and this concept we call as call by reference. So when you call a method by passing the object of the class, this is what we call as call by reference. It is not expected that it should be the pointer variable, just like C and C++. If pointers are not there, then also we can call the method by the reference. This mechanism is used to call the method by the references of it. So you can try this example given that along with this particular video. Now let's come with the third part of this particular tutorial, nested and the inner classes. Now the name will suggest the meaning of it. It is possible to define a class within another class. Such classes are known as the nested classes. The scope of the nested class is bounded by the scope of its enclosing class. Thus, if class B is defined within class A, then class B is known to A but not outside of A. A nested class has access to all the members of the class in which it is nested. However, the enclosing class does not have access to the members of the nested class. So let's see two examples I am showing over here: inner class and the method class. It's a very interesting concept to be used. Why classes are nested and why classes or methods are nested, that we'll see in this particular program. So let's see the first program, that is inner class. Okay. So this is how I declare the classes. So first class I am declaring here is outer. Okay, and inside that one variable is present called as outer x. Okay, now after this inside it, we have this constructor, we have one method called as test, and inside outer class I have declared this class. This is called as the inner class. Any name can be given, not required that should be inner. So any name can be given. So just to identify the concepts commonly, that's why I given the inner name there. Okay, so inner class is present. Inside the inner class, void display, one method I am declaring over here. Fine, this is how simple is that. So along with the method I have declared the class also inside this outer class. Now what properties it has? Inner class is known to the outer class only, means it is known to it. It can't be directly accessed outside of this particular class. Remember, directly I can't create object of inner class out of this. How to create that? Okay, that I will show. I can create object of this class here in test, because both belong to the same class. So inner is equal to new inner, and I want to call this display method, I will call in this way. Fine. So if you call it test, directly inner method can be called. So its object can be created inside this class only by any method in this mechanism. Okay, and if I want to create the object of this inner class out of it, I want to access the object out of it, or I want to call the display method out of the outer class, then how to create that? I can create the object of this class here. See, inner is equal to new inner. So here object is created, and if you want to call this out of it, so let's see, go to the main, and this is how we can call it. So first of all, I am calling the constructor of this class, this one. This 15 will go here, out x will be defined. Okay, and I want to call this display method. How to call that? Outer, this object, dot inner, this object, this one. See, they are highlighted together, and then display means first of all outer class object dot inner class object dot display method. Okay, so this is how inner classes can be accessed. Inner classes are a very interesting concept, that we can have a dot b dot c dot d dot, like inner, like in this way we can access the methods from multiple different classes which are nested together, and then based on that the call of variables or call of the methods can be executed. Okay, so this see, outer object dot inner object dot display. This is the way that we can make use of it. If you don't create this object here, see, don't create it, then it is not possible to access, because now it's showing error here. Directly display method can't be called. It's expected that this object should be present inside the outer class, then only I can access it. So it's showing error here, cannot find symbol inner. Okay, so that's why I have created this particular object, and I can call this by this particular method. So object name dot internal object name dot method name is a mechanism by which you can access the methods of the most inner classes out of the outer class. Okay, so this is how inner classes are formed and created. This method is used in many concepts in advanced Java programming also. So try to practice it and check the output. Now there is one more way to declare the classes. As I told, class is the user defined data type. Okay, so if it is user defined, anywhere it can be declared. So class can be declared in a class, or class can be declared in a method also. Okay. One more thing, just we have to remember that in previous program, I'll just revise it. See how many classes are there? 3. Outer class, this is inner class, and this is your main inner class. 3 classes are there. What do you think? How many class files are created for this particular program? Okay, let's see how many class files are there. Obviously 3 classes are present, so 3 class files should be present in it. I'll go to my NetBeans folder. Okay, NetBeans project. Inside that, what was classes, and in this we are having the build classes. See, inner classes, how many classes are present there? Inner. Okay, sorry, we have not executed the program yet, so let's execute this. Yes, so outer is accessed. I'll see the classes created. How many classes? See, this is inner class, which we form over here, inner class dot class. Okay, this is outer class. Okay, dot class, and one more, outer dollar inner dot class. So 3 classes are formed, but there, how the significance are there? See, this is inner class is a internal class of outer. That's why dollar symbol is added in between them. Okay, so 3 class files are created. So whatever number of classes are present in your program, everyone will have their own classes created there. This is how it's present. So by this particular dollar symbol, we can find that this class belongs to this particular class. It's inner class of it. That's why it's showing something like this. Okay, so that's what I need to focus on, and we'll go for the second method, that is method class. As I told, object data type class is a data type, a new data type created. That's why that data type I can declare anywhere, whether we declare inside the class or we can declare inside the method also. So I can declare a class inside a method. See, inside the main I declare this method class my class. Okay, inside the method. So here class, inside that method, inside that I'm having class. Fine. So my class, just a variable, I'm initializing it, and then a method I'm calling it, and then I'm creating object of it. So just see, the object is created, and I'm calling display your value 63. Simple, just like previous example we have seen. But the location of class declaration here is different. Here I declared the class inside a method. But what's the disadvantage here? The disadvantage is that this class and its object can be created within the main method only. This class is not having any visibility outside of the main method. If you want to access it out of the main method, then you have to create the object within it, and then I can access it. Directly accessing is not possible. So it is bounded by the scope of the main method. Visibility is limited within the main method. That is what disadvantage that we can consider for this particular concept of method classes. Okay, and if I run this particular program, it's very simple, that I just declare and created the object, and nothing more statements are written inside it. Okay, so let's run this file. Okay, your value is 63, as it is I am getting it, and if you want to access out of it, it's not possible because it's bounded by the main. That's why it is not possible. So this can be declared here in class also, in method also, and in out of all the classes also. So 3 locations where class can be declared. Class can be declared in the global scope, means out of all the classes. Class can be declared inside another class, it's called as inner class, and class can be declared inside a method, that is called as a method class. So I executed this particular program, and let's check the class files created for this. So here we have 2 class files. See this. Method class $1 my class. So method class is a class name, and inside that my class is another class name which is formed. Okay, so 1 will signify that this number method in which it is declared. It's a method class. So 2 class files are created for this particular case also. Okay, so this is how the classes can be declared anywhere in the program. So 3 concepts we have seen here. Static members. First, static members means the members who are initialized once and used by all the object of the class. Second concept that we have seen, it was called by a value and called by reference. We can call a method by passing a value, or we can call a method by passing an reference object also. And third that we have seen, it is nested and inner classes. We can declare a class inside another class, and we can declare a class inside another method also. So as per our requirement, we can make use of these particular concepts in Java programming. Okay, so this is what the part of the 7th video. From next video onwards, we'll continue with the more properties of object oriented programming in Java. Thank you. Thanks a lot.